The DART mission is designed to save Earth from an asteroid,
DART is our first planetary defense mission,
defending against asteroids like this one, Bennu. We're bombarded by almost 50,000 kilograms of space rocks every day. Most are tiny and burn up in the atmosphere as shooting stars. But some bigger ones can cause real damage, like this meteor in Chelyabinsk, Russia in 2013, which exploded with the power of 13 Hiroshima bombs. And that was only 17 meters wide. By comparison, the asteroid that killed the dinosaurs was 10 to 15 kilometers wide. And now there is another asteroid on its way. Bennu is about 0.5 kilometers wide, about as wide as the Empire State Building is tall. Between the years 2175 and 2199, there is a 1 in 2,700 chance of Bennu impacting Earth. Doesn't sound like much of a risk, but if it does hit, it will have the power of 80,000 Hiroshima bombs. But don't worry, NASA and the European Space Agency are on it. Enter DART, the Double Asteroid Redirection Test. Developed and led for NASA by Johns Hopkins University Applied Physics Laboratory, it does what it says on the tin, really. At least, that's the aim.
DART is a demonstration of the kinetic impact technique, just slamming a spacecraft into the asteroid.
Brilliant.
I'm Lindley Johnson. I am NASA's first ever planetary defense officer. This mission will demonstrate that humankind doesn't have to worry about going the way of the dinosaurs.
Why double?
It is called the Double Asteroid Redirection Test because we are targeting a binary asteroid system called Didymos, which means twins, and impacting the moon to change that moon's orbit around the larger asteroid. The impact affects an asteroid the size of Dimorphos, the moon of Didymos, 160 meters or so in size, the size of a small football stadium, would be an area of a small United States or a European nation. So it's important that we be able to protect life on Earth with this capability.
DART is set to hit Didymos in autumn 2022. We'll be able to measure some of the impact from Earth, but another spacecraft is heading that way. The European Space Agency's Hera will arrive around 4 years later to assess the outcome of DART's mission. But why go to so much trouble when Didymos isn't even at risk of hitting the Earth? Because Didymos isn't the only thing out there. There are over 20,000 asteroids close to the Earth, of which 1,200 are considered high risk. Thankfully, people like Richard Kowalski scour the night sky to find asteroids before they find us. They're known as the asteroid hunters.
As you can see on this screen is the sequence of 4 images that came from the telescope. These objects around the screen are not moving, so we know that they're stars, but this object in the center is moving, and thus we know that it's an asteroid. The importance of surveying for near-Earth asteroids is asteroid impact on the Earth is truly the only natural disaster that we can actually predict before it happens. The Earth has been hit in the past and will be hit again in the future. What we'd like to do is to be able to discover these objects before they hit the Earth.
Observations collected are all sent to the Minor Planet Center, and if they are asteroids that could come near the Earth and be a potential impact hazard, that information is sent to the Planetary Defense Coordination Office at NASA. If an asteroid is a more immediate threat of impact, I actually get a text notification on my smartphone. At NASA, we're kind of the Uber asteroid hunters, maybe is what you could say.
So what would happen if an asteroid did hit Earth? Well, we all know impacts leave craters, but what else happens? Because it's not just the collision itself that would cause devastation.
So for this experiment, we're going to fire this tiny 3/4-inch aluminum sphere at very high speeds, up around 5 kilometers per second. And then we'll see what type of crater it produces. So we use sand because it records the shock effects very clearly.
Pete Schultz uses super high-speed cameras to capture every detail of the impact and aftermath.
High voltage, the paddle is in, warning lights, and rolling.
The ball travels 15 times faster than the speed of sound. And like some asteroids would, incinerates on impact.
Oh, perfect, perfect, perfect. Now we're seeing the fireball come in. It's brighter than the sun, and then kapow! It hits the surface, jeez. This whole region downrange would have been incinerated. It would have been incinerated just by this plasma, this exploding vapor plume engulfing everything. There would have been winds that would have been going so fast it could pick up houses and spread them hundreds of kilometers away. This would have been Armageddon.
So all eyes are on the DART mission. And there are a couple of other asteroid deflection ideas floating around too. Some of them are wild. Here are some of the top ones. 1. Nuke it. Very Hollywood, and probably the first thing you thought of too. Great in theory, but could result in radioactive debris raining from the sky. Not ideal. 2. Gravity tractor. Sounds very space farming, doesn't it? The idea here is to fly a device next to an asteroid, so it slowly pulls it away from the Earth's path. This offers a lot of control, but it might not be effective for anything over 500 meters in diameter. 3. Paintballs. Yeah, you heard right, paintballs. Personally, my favorite suggestion. First, the act of shooting the asteroid would deflect it. And also, using white reflective paint means that the force of the sun's photons would theoretically push the asteroid even further off course. The downside? You'd need about 20 years' notice for it to work. So, we've got paintballs, tractors, and nukes, which might all seem like crazy ideas, but they're serious contenders. For now though, it's all eyes on DART and its mission to save the world.